In this tutorial, I'm going to talk about Julia Dictionary and Julia Set. Many of the functions introduced so far have been shown working on arrays and tuples, but arrays are just one type of collection. Julia also has other types of collections. A simple lookup table is a useful way of organizing many types of data. Given a single piece of information, such as a number, string, or symbol, called the key, what is the corresponding data value? For this purpose, Julia provides the dictionary object, called DICT or dict for short. It's an associative collection because it associates keys with values. Creating dictionaries. You can create a simple dictionary using the following syntax. The variable dict defined over here is now a dictionary. The keys are A, B, and C. The corresponding values are 1, 2, and 3. The equal greater than operator is now called the pair function. In a dictionary, keys are always unique. You can't have two keys with the same name. If you know the types of the keys and values in advance, you can and probably should specify them after the dict keyword in curly braces. You can also create dictionaries using the generator comprehension syntax. Use the following syntax to create a typed empty dictionary. Or you can omit the types and get an untyped dictionary. It's sometimes useful to create dictionary entries using a for loop. As you can see, in the for loop, I use the enumerate function, which returns the index of the list and the data that is contained in that index of the list. For example, in index 1, we have a.txt, in index 2, we have b.txt, and in index 3, we have c.txt. We have created a fvars dictionary and stored the key value pairs in this dictionary. This is one way you could create a set of variables stored in a dictionary. Looking things up. To get a value, if you have the key, you can use the following syntax. As you see, I assign a dictionary to dict variable and I use the key value to get the data that is stored in a dictionary. For example, I call dict A and I get the value 1. To get a value, if the keys are symbols, we use the following syntax. And if the keys are integers, we use something like this. You can use the get function and provide a fail-safe default value if there is no value for that particular key. If you don't want get to provide a default value, use a try-catch block. To change a value assigned to an existing key, we can use the following syntax. Keys. Keys must be unique for a dictionary. There is always only one key called A in this dictionary. By this dictionary, I mean the dict variable that we have already assigned a dictionary to in the previous section. So when you assign a value to a dictionary that already exists, you're not creating a new one, just modifying an existing one. To see if the dictionary contains a key, use hasKey function. To check for the existence of a key value pair, we use the following syntax. To add a new key and value to a dictionary, use the following syntax. You can delete a key from the dictionary using delete exclamation mark opening and closing parentheses, that is delete exclamation mark function. I call the dictionary to show its elements and after that I apply the delete function. As you can see, the key and value of the D string as the key has been removed. You'll notice that the dictionary doesn't seem to be sorted in any way. At least, the keys are in no particular order. This is due to the way they are stored, and you can't sort them in place. To get all keys, use the keys function. The result is an iterator that has just one job, to iterate through a dictionary key by key. The syntax that I'm already typing, that is, I'm using the list comprehension for, that is, opening the bracket new element for loop variable in iterator, and each new element is collected into an array. An alternative also would be using the map function. That is, we use the map function, pass the uppercase function to it as the first argument, and as the second argument we pass the iterator, which is returned from the collect keys dict. Values of the dictionary. To retrieve all the values, use the values function. That is, pass the dictionary to the values function as the argument, and you'll get the values of the dictionary. If you want to go through a dictionary and process each key value, you can make use of the fact that dictionaries themselves are iterable objects. So you can use the for loop and iterate through the elements of the dictionary and print them one by one, where the kv variable is a tuple containing each key value per in return. Or you could do for k in keys and pass the dictionary to it and print the key values. Even better, you can use a key value tuple to simplify the iteration even more. Here is another example where I iterate through a dictionary and put the elements of the dictionary in a tuple and print them one by one in each line. Notice the string interpolation operator, I mean the $sign. This allows you to use a variable's name in a string and get the variable's value when the string is printed. You can include any Julia expression in a string using $, opening parentheses, putting the variable name and closing the parentheses. Sorting a dictionary. Because dictionaries don't store the keys in any particular order, you might want to output the dictionary to a sorted array to obtain the items in order. For example, over here I iterate through the iterable object which is returned by the sort function, and we pass to the sort function as an argument the collect keys dict. Sets in Julia. A set is a collection of elements just like an array or dictionary, with no duplicated elements. The two important differences between a set and other types of collection is that in a set you can have only one of each element, and in a set the order of elements is not important, whereas an array can have multiple copies of an element and their order is remembered. You can create an empty set using the set constructor function. As elsewhere in Julia, you can also specify the type of the elements inside the set. For example, over here I assign to the variable primes a set with elements of type int64. You can create and fill sets in one go by using the set and specifying the type, for example, a string over here, and putting, for example, the name of the colors inside it. You can also let the Julia guess the type of the elements inside the set. So it returns the set of type a string in this example, because we are passing the name of the colors which are a string to the set. Quite a few of the functions that work with arrays also work with sets. Adding elements to sets, for example, is a bit like adding elements to arrays. You can use push exclamation mark function. You can pass the sets variable name as the first argument to the push function, and as the second argument you can add the name of the element or the value of the element that you want to put inside the set. To see if something is in the set, you can use the in function. For example, in and the color green inside the colors set. If it returns true, it means that the green color or green string is inside the set as an element. There are some standard operations you can do with sets, namely find their union, intersection, and difference with the functions union, intersect, and set diff. For example, over here I define a set called rainbow that contains the colors of the rainbow. And then I use the functions union, intersect, and set diff to show the operations that you can perform on the sets. The union of two sets is the set of everything that is in one and the other set. The result is another set, so you can't have two yellows here, even though we've got a yellow in each set. So the elements are not repeated and they are unique inside the set. The intersection of two sets is the set that contains every element that belong to both sets. The difference between two sets is the set of elements that are in the first set but not in the second. This time, the order in which you apply the sets matters. The set diff function finds the elements that are in the first set, I mean colors, but not in the second set, that is rainbow. Now we go back to the dictionaries. I've already defined two dictionaries, D1 and D2, and the operations union, intersect, and set diff apply to dictionaries as well. There is also a merge function which can merge two dictionaries. Functions that work on arrays and sets sometimes work on dictionaries and other collections too. For example, some of the set operations can be applied to dictionaries, not just sets and arrays. Over here, I define the dictionary D1. The find min function can find the minimum value in a dictionary and return the value and its key. If you are enjoying the content, don't forget to hit that like button and subscribe for more awesome videos. Your support means the world to me.